Today I am very excited for one of my long-term quests to end because I finally got my hands on this, a TRS-80 DT-1. What is a DT-1? It is a serial data terminal. Before we get started, you should know that this video is part of a series of videos by several YouTubers this month that we are calling Sep-Tandy. So if you enjoy this look at a TRS-80, you might want to also check out Adrian Black, Dave Just Dave, and Mr. Lurch for more videos on them. I'm going to have a lot to say about this, but one of the things that might strike you at first is that it looks a little oddly familiar, doesn't it? Well, that's because it is in a TRS-80 Model 4 case. Or is it? We'll take a look at that a little later. First, why would Radio Shack offer a terminal? Let's begin to answer that by taking a look at some of the computers that Radio Shack made. The TRS-80 microcomputer system, later known as the Model 1, was released in 1977. This computer was designed with a Zilog Z80 processor, which is where the 80 part of the name comes from. The successor to this was the TRS-80 Model 3, released in 1980. The final system in this line was the TRS-80 Model 4, released in 1983. You likely noticed that the models went 1, 3, 4, and those are all the models in the System 80 line. But there was a TRS-80 Model 2, it was just part of the new business computer line started in 1979. The Model 2 also used a Zilog Z80, but was designed completely differently, being incompatible with the 1, 3, and 4 software and hardware. This line continued when the TRS-80 Model 16 was released in 1982. The 16 introduced using a Motorola 68K CPU. There was then the TRS-80 Model 12 as an incremental upgrade to the 2 in 1983. Finally, this line was concluded when the Tandy 6000 was released in 1985. So where does the DT-1 fit in with all of this? Well, it was released alongside the Model 16 for $699 in 1982. The 68K processor made running Unix-like operating systems with multi-user capabilities easier than ever. But in actuality, you could use the DT-1 with all of these computers, and the manual even tells you how. But really, the DT-1 would have just been used with the business computers, especially the Model 16, which could run Xenix, which made it a true multi-user system. But the DT-1 does have a drawback that was addressed in 1984 when its successor was released, the DT-100. It is just a rebranded WISE WY75, but it is a capable VT-100 terminal, something that the DT-1 is not. For more information on that, let's turn to the original manual. These are 4 different terminals that were released that the DT-1 can pretend to be by interfacing with the host in the same way as them. I could keep going about the small things on the DT-1, but we should really get moving on because this thing needs some work. But there is one last thing I want to touch on before we continue. Now, I mentioned the DT-1 is a terminal in a Model 4 case. Well, actually, the DT-1 is from 1982, and the Model 4 is from 1983, meaning the Model 4 is a computer in the DT-1 case. However, though, the DT-1's case is just a textured white Model 3, so really it's not the origin of that shape. Now with these next to each other, you can really see that the DT-1 is pretty filthy, so we should get moving on. I'm borrowing this Model 4 just for this comparison, and it's not the focus of this video, so I'm going to get it out of here so we can continue. Alright, now let's begin to focus on this DT-1 in particular. Obviously, this thing is in rough shape, and it's going to need a bit of work to get going, and I've already been in it to get an idea of what needs to be done. Matter of fact, I've already ordered parts, so we don't have to wait for some stuff to get shipped. Hopefully. So, let's go ahead and start to break down everything that needs to be done to this thing to get it up and running again. Alright, I'm going to make this list as we work our way outside in and have it in the order of least to highest priority. So the first thing is that this thing is dirty. Oh, man, is it dirty. Look at, oh, wow. So, yeah, it's going to need a very, very good cleaning, just to be at a point where you'd actually want to touch it. Next up is, oh, man, the keyboard. The keyboards on these unibody TRS-80s are notoriously unreliable. These keys inside are individual switches that are soldered to a circuit board, so 2 contacts, just like usual, and they can be disassembled, and likely will have to be, because inside each key switch is a carbon pad and a contact point. and those get dirty, and then the switches don't work. So you have to disassemble the entire keyboard. It is an excruciatingly long process, and I'm assuming I'm just gonna have to do that. I did do that on that Model 4 that I showed you for the person that I borrowed it from. It took so long. Matter of fact, I kind of blacked out that memory. I don't even remember most of it. It was such a horrible experience. For the remaining problems, we're going to need to open this thing up, and thankfully this is nowhere near as hair-raising as for the Model 4 or 3, because there's no PCB hanging out near the back of the CRT. It's almost impossible to break the tube on this, unlike a Model 3 or 4. Those are frustratingly easy to damage, actually. Here's the sticker on the bottom of my DT-1, if you're curious. Now, this has a serial number of 41. That's pretty darn low. But confusingly, all of the date codes inside are from 1984. Now, we've already established this thing came out in 1982 with the Model 16. So this is weird. And it's not just like the case or just the chips. They match. The case has a date code of 1984, and the chips have date codes of 1984. It's very strange. Alright, now here's our first serious problem. This is the connector that goes from the logic board to the main display board here, and, well, you see, right here, yeah, there's a bit missing that connects to a pin over here. It's actually in this piece of tape. As I mentioned, I've been in here before. The card edge connector here had cracked, and that one pin got snapped off in there. So one problem we're going to have to fix is the CRT board. The next two things make me a little less than thrilled about this exact example, but this is the only DT-1 I've ever seen. Okay, so first off, this fan doesn't belong in there. Someone added this. This is the cable coming off of the fan. I put this vinyl tape on there. It's just bare wire. These bare wires were shoved into the back of the CRT connector, just kind of crammed in here. Now, that's really terrifying. I can't believe in the 1,600-mile drive back from Canada, because, oh yeah, I bought this from Disappearing Ink in Canada, that those managed to stay in there and throughout its entire life. I mean, frankly, this thing probably hasn't been turned on in decades, and it's been transported and all sorts of stuff, and that was intact in the connector. It's just amazing. But I don't like this at all. I don't know if this thing really runs hot enough to warrant adding a fan, but I'm going to remove that. Also, the hub to blade ratio there tells me that thing's going to be super loud, and even if I put a fan in here after the fact, it's not going to be that one, because that one's going to be unbearably noisy. Now, this is obviously less important than the CRT board, so I'm going to put it up there. But the next thing I want to take a look at, I don't know, it's debatable whether or not it's as important as the CRT board. Before we move on though, if you look right beneath the fan here, you can see the floppy drive bays where they put the black filler plate that says DT-1 on it. Alright, we're getting further and further into this thing, and just wow, compared to a Model 3 or 4, this thing is barren inside. So to give you an idea, the floppy drives go right here on a Model 3 or 4, the power supply mounts right next to that, and the CRT goes right here. This would be the main board on a Model 3, 4 equivalent, but it's not mounted like that. It's mounted straight up along the back, and that's why the tip of the tube is so close to the Model 3, 4 main board, and it's just terrifying. There is a board, well, not quite a board down here. This has actual D-sub connectors on the board. You can kind of see the pins here, and we'll take a look at that in a moment. Whereas the Model 4 has card edge connectors poking down. So it does not have a board that runs parallel to the case like this. It's always perpendicular. But just, oh man, this thing's really nice to work on. Model 4 just sucks. Alright, now not as important as the power supply, but still I think important is what's going on with this main board. But it looks pretty normal from here, so I'm gonna have to take it out to show you the other side for you to really understand what's going on. This thing is held on with plastic posts that were glued to the case. I'm not sure what on earth they were thinking here, but this thing is really poorly attached to the chassis. I was gonna say computer case, but it is a computer case. This is just a terminal inside of it. Alright, so here we have the main board, and the thing that concerns me about this are all the bodge wires on here. Why? Just why? Now, as I mentioned, this has a really low serial number, but all the part dates are 84, like the Intel chip here. And as I mentioned, this has an Intel CPU. What it actually is a microcontroller. This is an 8051. So that is the main brains for this computer. Over here, we actually have an 8276 CRT controller, and then this will be the character ROM, and we can see it's custom Tandy there. So that's the main layout of this thing. But these bodge wires, so I can find one instance of another one of these being opened online, and it's from Nightfall Crew. Theirs has none of these things going on. Now, their chips are dated 82 on here, so they have an earlier board, I guess, but why? So I want to just, in case these are actually needed, go through and check all the wires that they're actually still connected and functional, just to make sure there's no floating things. And some of these solder points are really gross on here, so I just want to make sure that there's no corrosion or anything going on. And kind of funny, a lot of the parts in here are 84, like I said, but there are some much older ones like this 1979 part here. So they clearly bought in bulk and held on to stock. And lastly, removing the power supply. In a brilliant design choice, Radio Shack mounted the power supply upside down in this enclosure so it can't breathe at all. One more thing before we move on. Now, I don't know if the Model 3 has this. I've never seen one in person and I haven't looked it up for this. But I do know the Model 4 does not have this. These meshes over the vents, I don't know if this is to keep dust and hair and lint out, or just as some kind of vain RF shielding. I don't know. I think, yeah, it's metal. It's just kind of weird. It's clearly cast into the case. I mean, we have the plastic welds here. Those were likely posts that were poking up. So, yeah, it's kind of strange. At some point, I might want to check the bottom of the Model 4 and see if it has this, but I know this is also on the top of the case as well, so it's just kind of weird. I don't know if there were posts inside the Model 4 that weren't melted, but there's definitely no mesh. Just kind of strange. And here we have the power supply. Now, there are a few things that I want to talk about here. So, first off, this is not specific to the DT-1 in any way, and because of that, we can see that we just get regular voltages out. We got 12, is that negative 12? Or, it's 12 by 1 amp, 12 by 2 amp, 5 volt, and 2 to 2.5, 2 to 5 amps, I guess. I don't know. We'll probably measure the voltage out here just to be sure before we put this thing back together. But this is just a very, very standard power supply. You connect your mains voltage here. I'm sure somewhere there's a way of changing. No, it looks like it's locked 115 volts. So no 240 volt switch here. But it can support 50 hertz. That's really strange. It is just outputting DC, I guess. So it doesn't make too much of a difference. But yeah, there's a few things to go on here. We'll get to the obvious one in a moment. But these 2-watt resistors have, whoo boy, clearly been used a whole lot. So this is obviously not a low mileage example of a DT-1. Matter of fact, I did spot some burn-in on the CRT. I'm hoping it's not too bad. But yeah, so those might be getting close to expected end of life. I might want to measure the resistance on those, make sure they are still close to spec. This is interesting. I wonder what's going on here. What on earth are those? Those are really weird. Why are those heat sinked? Diodes. Heat sinked diodes. What? Now I kind of want to look up a schematic for this. I think I actually did find a schematic, but those are strange. Yes, that's really weird. Anyway, okay, let's talk about the big thing here. Not too long ago, I had my first experience with a bad Varta battery, and yeah, that was pretty bad, but not as horrible as it could have been. Well, I was prepared, based on the experience of others, to double check this thing, especially based on online research, and it was a good thing. this is an X-type line filter capacitor, and this one is not doing well. This is an actual Refurb brand capacitor as well. This likely would have blown up the instant I turned not even turned on, just plugged in this computer, because this is connected directly to mains on here. You can see this resistor goes just straight to mains. So yeah, that would have blown the instant that I plugged this in, which is why I had the big tape on the front that said do not turn on. I actually had the outlet connector taped over so it couldn't be plugged in without intentionally working against myself. So this is the very first thing I'm going to repair by removing and replacing this. Now, when it comes to repairing a line filter cap, a lot of times you can get away with just removing it, at least based on what I've heard from other people. But I'm not really that fond of that solution. I really want to use this DT-1. I want to use it as like an interface to my server and stuff. So I would rather it just be correct and not damaging itself, wearing out other components, heating them with unnecessary voltage fluctuations, etc., etc. So I am going to properly replace it. I've ordered 10 Panasonic X-type capacitors. These don't say X-type on them, which kind of weirds me. Oh, here we go, X2. Now, this should be a fairly drop-in replacement. It's obviously a smaller package, but that's not going to be a big deal. I ordered 10 of these because I also want to do that Model 4, which, yay, disassembling a Model 4. But it's better than having it blow up. Now, there are variations of this power supply. It's, yay, not just the 0.1 microfarad cap that can be in here. There is another variation of this that has another cap right here. I don't have that one, so I didn't order those caps that might be in that Model 4. I don't know, and I won't know until I open it. So when I open that thing, it's staying open until the power supply is done. Anyway, back to this. I'm just going to repair this by replacing it with one of these, and I'm never going to turn it on without a line filter cap in there, just because I want to protect this as much as possible. Now, long term, if this does fail, those voltages are very, very standard. I could extremely easily mount an ATX power supply in here. It doesn't even have to be Pico PSU. I mean, it could be. This thing probably outputs like no power whatsoever. But well, I should say, not that this outputs no power, it's that this draws no power. We have a microcontroller and a CRT. The whole thing's actually only rated for 20 watts. The DT-1 rated for 20 watts, which, as a side note, kind of dispels the myth that CRTs use a lot of power. This whole terminal uses 20 watts of power, and that includes the CRT. Anyway, I could just replace this super easily. That's all there is to it. So this is a preventative measure to keep this original, but I'm really not beholden to this power supply in any way. And there we go, replaced. It's a little smaller than the original, but they had 2 pitches for the spacing on here, so it seems like they were going to accommodate this size line filter cap all along, so convenient. But I'm very happy to have the Refurb out, and now we can cross the first repair item off the list. Alright, power supply is reconnected, and we're going to check the voltages now. So the little markings that were here I was mentioning earlier actually tell you what the pinout is, and it's the same across all 3 connectors. So these cables that you plug into the power supply, you don't have to worry about which one goes where. The one that goes off to the main board here, labeled, I guess, CPU, has the color coding for everything. So white is -12, orange is 12, black is ground, and 5 is red. Okay, so we can turn this on and you'll actually see the lights flicker a little bit, or maybe not. Might be getting better, I don't know. And I'm going to now very, very, very carefully measure the voltages here so you can see them. This thing does not have a fuse, so if I slip and short these, there is no protection. Okay, -12 is -9. That's probably totally fine. It's ground to ground. 12 is 12, and 5 is 5. All good, no problems at all. So, power supply, fully functional, working, sweet. Now obviously that's without a load. It could perform poorly with a load, but we won't know that until later, and really 20 watts, not a lot of load there. While I had the camera set up for this angle, I figured I'd go ahead and find out how bad the keyboard is going to be, and I think I really lucked out. So first of all, I forgot, the TRS-80 keyboards are extra horrible. They're not 2 contacts per key, they're 4. It's twice as much work as your average keyboard to desolder one of these. Anyway, measuring the contacts on the keys though, it looks like... Oh, come on. Yeah, 50 ohms. That is so much better than the condition the Model 4 was in. Yeah, and they're all looking like that here. It's kind of difficult to get this. There we go. 77. Yeah, so I am extremely optimistic about this. Yeah, there we go. I don't know about that one. I'm not getting a good hit connection to these. It's also like conformally coated or something. I might just be flux bath. I don't know. I've seen this on a bunch of old boards. Probably just the flux bath from wave soldering or something like that. So, but oh, the keys themselves aren't looking like they're in that horrible condition. I'm gonna put this back in and just cross my fingers that the keyboard works, because I think I might luck out here. And you know what, since I have this removed, I'm gonna go ahead and clean it. It's gonna be the easiest it can be right now. Oh, that is looking so much better. That is quite the change. It's gonna make the keyboard look just revolting. Oh, yeah, wow. There's some work left to do on that, but I'll do that later on, because I'm probably gonna want to remove all the keycaps. Maybe. I can't remember. Do these just come out cleanly, or do I have to desolder the key stems? If I have to desolder the key stems, those suckers are staying in, so, but we'll get to that later. The 128K badge is pretty uncommon, but I guarantee you're going to see a lot fewer of these. Okay, now a look at the main board. So it's stuff like this that makes me a little concerned about these bodge wires, because this is pretty bad. This is going to be all dry and crusty. I don't know how easily I'm going to be able to clean that off. I may give it a try, but I don't know, it's been on there for like 30 years. It may not be corrosive. I don't know. But these wires were clearly put on with some care. You can see it running under this resistor here. So they put some effort into it, whoever did this. It might be from the factory, I'm not sure. Yeah, we can see them running off all sorts of different places, going under all sorts of different things. Clearly trying to be well managed. So, but it's looking like they are all still pretty solidly connected here. So yeah, I may not have anything to worry about. I think that's all of them. There are really only 4 wires on here? I guess so. So maybe it's not as bad as I was thinking. But still, it doesn't hurt to check. I wanted to be sure, because I really want this thing to work. I know it's so weird, but I've been really excited about getting the DT-1 for a couple of years, and well, I finally got one, and I want to make sure that I keep it going as long as possible. I think I'll not worry about this for now, and then if this thing does end up working out just fine, I can put this as a to-do item to come back later, because I am going to be opening this thing back up. So I'm going to call this good for the main board. Okay, it's now time to take a look at the Crt board, and there's a lot to talk about with this. Okay, so first off, this pad looks an awful lot like ground, the one that's broken, and I have the bit here that should be attached. So we can see that this goes to this giant ground pour over here. Well, copper pour. We don't know that it's ground yet. But we can also see that this one over here does the same thing on the other side. And if we do a continuity test between what's left of that connector and the other side, we can see that it is in fact ground. But that's not necessarily the whole story. So these are the same, and this is the CRT interface connector. This is the main logic board, and this is the CRT interface chip. This is the connector that goes to the CRT cable that is attached to the case. And if we look here, the connector is somewhere in there. All of its traces. They're all going to the CRT chip, okay? What this means is it's probably just 12-volt logic signals that are going up to the card edge here, which means that it's really not that sensitive of a signal, so degradation isn't going to be too bad on this. But that's not the whole story. This is the card edge connector that goes from the logic board to this board. Now, we have the two grounds. Okay, so this one goes to this pin. We can tell by the keyed side. So this pin goes here. This one gets opened up. This is ground, and it is used as shielding for all of the cables that are going off to the logic board. All right, so we can see here it's split open, cables splayed out, shielding. All right, bam, and then it continues off and it goes to the logic board connector. Okay, what about the other side though? Well, the other side gets paired with this orange cable and goes off to this connector, which plugs into the power supply. So the ground that's broken is the main power sinking ground. So that's kind of a big deal. If we don't have this one connected, it's going to have to sink all the power through the shielding. So yeah, that's not ideal. Now, if we go back to the main CRT board here, we can see that they've done a pretty good job at keeping this ground on the power supply, which is actually power supply. We can see a fuse and everything here. All right. They've done a good job at keeping it separate from the logic ground. So yeah, we probably don't want to try and get those mixed up. Well, though here I'm seeing plus. That must be for whatever this is. Anode. Yes. So don't touch that. Poke, poke. This thing's probably been discharged for years. So we have power ground and shielding ground. These are kind of a separate thing. They're obviously connected inside because we are able to do the continuity test, but you generally want to keep these separate to avoid interference. Now, like I said, again, this is going to be logic level signals, 12 volts, probably not all that susceptible to interference. But still, we want to make sure that we are running this thing in the best possible way. So I'm going to play around with this a bit, see how I can reconnect this to the cable. Now, I don't think I'm going to get away with just super gluing that back in there and then tapping a little bit of solder on there, but I'll see what I can do. Like I said, I don't think that super glue and solder is going to work, but that doesn't mean I'm not going to try it, just because that would be a really convenient solution. Okay, here's what we've got. So I've put a just ton of solder on here. I get it focused. There we go. So that's a massive solder blob bridging the crack. And I put a ton of super glue on the other side. Well, I mean, as much as I can really do. I let this dry for well over an hour. So, I mean, that's got to be fully cured. So what I'm thinking is I might try and remove the cable from the chassis and then connect it onto here loose, because the bottom side of the case has a whole bunch of cable management clips and they're all zip tied in. So try and remove it completely and then plug it into here and then maybe somehow attach the cable to the board so there's never any strain coming off of the card edge. I think that might work. Don't know how practical that's really going to be. But let me get the cable detached and try connecting it and, well, see what happens. Oh, duh. Yeah, the cable goes off to the knobs on the side of the case for the image adjustment. So yeah, I can't remove it without taking this off, and that's way too much work. So I disconnected it from here, and, well, that gives me a lot more slack, so let's just hope for the best. Well, I made the solder a little too thick going down in there. I can try pulling this off, which will add more stress on there. Seeing if I can flatten it out, but leave the thick glob here. It's really, really tough, but I'll see. It might be worth the effort. Wow, that worked super well. That might be perfect. Okay. Wow, that worked out so well. I don't want to try putting anything on there now until I go to reassemble this, because I think that's going to work. Wow, it's hard to see. Look how sharp that edge is. That might be everything I need there. Okay. Wow, this may actually work. That would be crazy. Hesitant to scratch that one off. Also keyboard, so let's go ahead and just kind of do this as a way of reminding ourselves that we need to check back up on these. This is just going to be turn it on. Well, once I get it reassembled, I'll continuity check on the board itself to make sure that the two grounds are touching on the other side of the cable, because that'll answer all the question I need. But yeah, okay. Let's get that fan out of there, and then I guess take a look at it being dirty. But you know what? Once we remove the fan, I think we should try firing it up. Okay, I've got this on my lap because there's almost no way to film this that isn't awkward, but it looks like the fan might be glued down, so I'm just gonna try and pull it off the mesh. Hope that isn't the mesh tearing. Doesn't feel like it. Ooh, getting somewhere. I'm feeling glue left behind on the mesh, okay. Ooh, and that's going against the mesh. Ah, there we go. Oh, wow, that's horrible. What was this, 12 volt? Yeah, that was probably really, really noisy. Oh, that's awful. That was such a bad place to put a fan. There's so little actual airflow space in there. Wow. Oh yeah, that was really poorly done. Actually, you know what? For giggles, let's take this off because I'm just curious. One of the things I want to do for this is clean it anyway. So getting that off will help me clean it. There's a really annoying problem on the front anyway. Let's see, I guess I can just do that right here. It's just 2 screws, isn't it? A smaller screwdriver would help. Here's the iFixit driver.